Yeah, we can start.
Welcome everyone for the second session of Games of Chance. So uh, today I'll be continuing from where I left off yesterday. So yeah, maybe I'm just going to give a minute for everyone to join and settle down. So yeah, Madhusudanan, you have raised your hand. You have something to say?
Sir, you gave us a homework question last class, sir.
Correct. Yes. What was the homework question? You remember?
I know this. Sir, can I read it out?
Yeah, just the question.
Okay. Anita and Balu are equally skilled in a game of Go.
Mhm.
They play a tournament against each other. The cash prize, they bet 5,000 rupees each. The player who wins 5 games gets all the 10,000. Anita got the leading points of 4 and Balu got 2 points. How should and the game stopped abruptly in the middle. How should the prize be split?
Yeah, correct. So Sanjeev, do you have something to say?
So there was actually another homework question, and that was like, so you like if you roll 3 dice,
Mhm.
then the price is proportional to how rare the number is, and if the price of getting a 4 is rupees 100, then what should be the price for 12? That was another question.
Correct. Yes. Uh, right. So I would want to take off on from the splitting the price question. So the other question I will leave it open for now. In the end, if we have time, maybe we will discuss that. So yeah, the 3 dice problem. Yeah, I'll just leave it for you to work on. Yeah, Madhavan, do you have a question?
No, sir, I have an idea.
Okay, so Madhavan, idea for
The
the splitting the
splitting the
price.
price.
Okay, right. So yeah, we are going to discuss that. So yeah, you guys can lower your hand. Okay, so I think we are ready to properly start now. Let me share the screen. Okay, right. Okay, yeah. So we will start with the second session. I'll just quickly recall what all we did yesterday. Yeah, Ashwath, do you want to say something?
Sir, I just had a question.
Right.
I wasn't here last class, so
So yeah, Ashwath, I don't know how much you are going to catch up. Mostly it will be independent, but yeah, you just have to follow with what's going on.
got it.
Yeah. Madhusudan, do you want to say something?
Sir, can I share the answer?
No, not yet. I will tell you when you can share. Until then, yeah, we have to wait for the response. Yeah, you can lower your hand also. So this is what we did yesterday. We just had through the history of the games of chance. We looked at some dice games, rolling 2 dice and seeing what the total is, and so on. And I finished the session with a question on how to split the price. Right. We are going to discuss that in detail today. And yeah, if there is time, we will discuss a couple of other questions on games of chance. So the fundamental rules are still the same. You all have the right to be wrong, right to be different, and the right to question. And the ground rules are also there. So yeah, in case you need, if you have a doubt or you want to say something, raise your hand. If you have an answer, give me a thumbs up. Right. So raise hand means I will assume that you have a doubt or a clarification. Yeah. If you have an answer, yeah, you can give a thumbs up. Then I ask you. So I am a little anxious about this because yeah, I want everyone to have an opportunity to think on their own. So please be on mute so that your yeah, so that there is no background noise for the session. And when I ask you to unmute, you can then unmute and speak. But yeah, don't just start speaking, because I'll be looking at a different screen and I won't know who is talking to me. And yeah, it'll just be very difficult for me to understand also. And of course, the math rule, that is no claim without a reason. So whenever you make a mathematical statement, I expect you to give a reason for that. And same as yesterday, no help from the internet. So yeah, this I will just run through. These were the things that we saw yesterday. So we played the dice game where for a pair of dice, you had to guess the total. And we saw what are the totals which are possible. And we also tried to come up with a way where you are giving a price that is proportional to the odds. So for example, if 7 is very common and 2 is a rare total, if they get 2, they should be rewarded more, right? So we saw how to do that. And we saw how to calculate the probability of the sum being greater than 10, what the correct way to do it is. And yeah, we played the game with 3 dice, right? So this this is where I stopped yesterday. So we have this tournament between Anita and Balu. And yeah, as Madhusudan explained the question, it's a tournament where whoever wins 5 games is going to win the whole prize money. But after 6 games, when the score line is 4-2, the tournament is ended abruptly. And now we want to see how to split the prize. So now I am sure some of you would like to share your own way of splitting the price. But now what I want to do is I want to show you different ways where we can split the price, and I want you to see if they all are like a fair split, if they are a reasonable or a fair way of splitting the price. So let me go to Polypad. Um, yeah, right. Okay, I'll just put the facts on the corner so that it'll be available for us for reference. So Anita and Balu are playing. The score line is 4,2, and they are playing so that whoever wins 5 games is the winner of the tournament. Right. So now here is basically the first method. Method is to split according to the score line. So Anita has won 4, Balu has won 2. So maybe we should split the price in the ratio 4:2. So this is intuitively what many of us would think. In fact, this was the method that was common in earlier days also, in say 1400s or 1500s. That whatever the score line is, we will split according to that proportion. So you are splitting it in the ratio 4:2, which is of course the same as 2:1. So now I want to know how many of you think that this is a fair way to split. Give me a thumbs up if you think it's a fair way to split the price in this proportion. So I'll just give you a second to think about it. Okay, so yeah, Farhan, can you explain why you think this method is good? Anandraj.
Sir, this method is right because uh, when we are splitting according to the score line, we will get we will get a accurate accurate answer because the score line will show very easy step.
Okay, Farhan. So yeah, fine. So Farhan, you think that this is a fair split. Is there anyone who thinks this is not a fair way to split the prize? That is, splitting it according to the score line. Whatever ratio the score line is, we will split in that. So yeah, I can see many hands go up. So yeah, maybe I'll ask Malolan. Malolan, why do you think this is not fair?
Sir, but maybe like this is unfair because the game is supposed to be 5 matches and the planning won't go according to it. They would have planned differently or something. So the game should remain as such. So there should not, the solution doesn't hold. It's just too early to decide.
Right. So basically, we don't have a choice. That is, of course, the initial agreement was they will play games until someone wins 5 games. But now the tournament has been cut short for like unavoidable reasons, right?
Sir, but I have a different idea. Can I
Okay.
just say it?
Yeah. What's your idea?
So let's calculate the win probability for both of them,
Mhm.
and we can do it according to that. So the win probability is so let's the first case let's take 3 matches.
Okay, yeah. So Manulan, I'll come to your method. Yeah, I can see what your idea is. I am going to come to that method, but before that, I want to show a couple of other methods also. So yeah, Manulan, I'll come back to you later. So yeah, Ashwath, why do you think this is not a fair way to split?
I don't think it's a fair way to split because, again, as Malolan said, it's better to look at the probability of each person winning at that position, and also four is to two wouldn't be the split of the probability. Yeah,
Okay.
yeah, yes.
You both are saying we should assign the prize according to their probability of winning, and you are saying this score line is not a fair way. But the score line could also show the probability, right? So maybe Anita has a probability of 2/3 and Balu has a probability of 1/3, right? That could also be the case. So yeah, Sanjeev, why do you think this is not a fair way to split?
So this kind of method would make sense if they were to play a unlimited number of matches in a certain fixed amount of time. But in this case, because you should stop abruptly because of like some particular circumstance and the main objective is to win 5 matches, it does not make sense. Thus, we should find a probability of each player winning 5 matches.
Right. Yeah, fine. So I can see that all of you are saying that we should look at the probability of Anta winning the tournament or Balu winning the tournament and split accordingly. Right. But now I just want to like show you why this method is not fair or why this would not correspond to the probability of them winning. So one thing is here the score line is say 4:2, right? And so you are splitting the price as uh, in the ratio of 4:2 or 2:1. But suppose imagine that the score line had just been 1-0. That is, there was only one match played, and Anita won the first match, right? And now, if the tournament had stopped at this point, you would have simply given all the prize money to Anita. But even though there were like still a lot of games to go, there was 5 games to win, and Anita won just the first game, you would be giving her all the prize. This is what you would be doing even if there were 100 matches to win, right? So even if it was the tournament that awarded the person who won 100 games the prize, if Anita just won the first game and the tournament ended at that point, she will be getting all the prize money. So that is why basically if you are looking at these kind of different scenarios, this method of splitting does not seem very fair. So this is not fair. But then I want to show another method also. Split according to remaining points to win. So here, for example, Anita has won 4 games and Balu has won 2 games. So now Anita has to win 1 game and Balu has to win 3 games, right? So now maybe because it is so easy for Anita to win, just give me a second, I'll be with you. Yeah, sorry about that. So because Anita is so close to winning, of course you want to give her more money. But maybe the proportion should be 3 to 1 because Balu has to work like 3 times as hard to win the prize money. So maybe we should split it in the ratio. Anita gets 3/4 of the prize money and Balu gets 1/4. So now, how many of you think that this would be a fair way? So this could also be the probability of them winning. So the probability, if you are assigning the prize money according to probability of winning, it could turn out that that number is also same as this. So how many of you think that this method is a more fairer way of distributing the prize money? So if you think that this is a fair way, give me a thumbs up. Okay, Viren, I can see a thumbs up. Okay, so now how many of you think it is not a fair way? So how many of you think it's unfair? Raise your hand. So yeah, Kamal, can you explain your argument? Kamal Nayan. Yeah, Arav, can you explain your argument why you think it's not fair? Arav Lam.
Sir, I think it's not fair because this is almost the same as method 1 because we're just seeing how many remaining matches they need to win, and then we're sort of, you can say, inverting the ratio, which comes out to the same thing.
Yeah, correct. So this is just a modification of method 1. Of course, this modification gives like a bigger chunk of the prize money to Anita. Got 2/3, or we split in the ratio 2:1. But here we are giving in 3:1, right? So Anita is definitely getting more money. But even this would not be a fair way to split. So, for example, let's just think of applying the same rule in a different context. So suppose if A and B were playing for say 100 games, that is they win the tournament if they win 100 games. And if Anita is on 99 and Balu is on 90, we will be splitting the prize in the ratio 10:1, right? But Anita is so close to winning the whole thing. She just needs to win 1 game, but Balu needs to win 10 games. And it is not just 10 times harder. In fact, it is much more harder than 10 times. So even in this score line, when the score line is 99 to 90 and the tournament is cut short over here, Balu will be getting only like 1/10 or like 1/11 of the prize amount. But even that is so unfair because Anita should actually, she deserves to win and she has come so close to winning. So even that 1/11th is being too generous to Balu. So now you can see that yeah, this method of splitting the prize in the ratio of remaining points, that is also not a fair method to split. Before I go to calculating probability, I want to show one more method. So yeah, this is also kind of probability only. It's odds of winning. So what I would argue is to win, A needs 1 win and Balu needs 3 wins, right? So now both of them are equally skilled players. So both of them have a probability of half of winning the game. So now for Anita to win 1 game, she has the probability of half. And for Balu to win 3 games, it's going to be half into half into half. So half cube, right? Because Balu needs to win 3 games, it's half cube. Anita just needs to win 1 game, so it's just 1/2. So maybe I will say we will just split in the ratio half is to 1/2 the whole cube, which is basically the same as saying I'll split in the ratio 8 is to 2. Right. So would this be the correct way to calculate the probability of winning for A and B? So yeah, if uh, yeah, if you agree or disagree, you can raise your hand. So yeah, Ashwat, do you want to say something?
Yes, sir. I don't think this is right, sir, because first of all, since like it's one or the other, A wins or B wins, the sum of the two probabilities needs to be one, which is not the
Correct.
case, and also the probability of A winning is not half because B could also win a few rounds before A wins. So A just needs to win one round, but B could win 2 rounds before that, one round before that, or none. So it would actually be like half plus 1/4 plus 1/8. I think. So it would be 7/8.
Yeah, correct. So yeah, Ashwat, we will come to that number in just a moment. But yeah, I'll just explain for the whole class. So as Ashwat mentioned, number one, we are not calculating the probability correctly because here either A has to win the tournament or B has to win the tournament. That means the sum of their probabilities has to be 1. And here, of course, if I'm giving the probability of half to A and 1/8 to B, that the sum of the probabilities is not adding up to 1. That is the first thing. And second thing, as Ashwat mentioned, I am saying Anita needs to win 1 game, but it doesn't have to be the next game. It could be that Balu wins the immediate game and Anita wins the game after that, or Balu wins 2 games and then Anita wins the game after that, and so on. Right. So now I want to show 2 methods. One was the method by Fermat and the other is the method by Pascal. So both of them tried to split the price based on the probability. And now they came up with a way to measure that probability. So before I discuss that, maybe I'll ask Malolan. So Malolan, what was your method to split the price?
Like I did not use conditional probability. I just used normally just did casework. So
Right.
let's so there's one case. Let's say they play 3 matches, 3 more
Ah,
matches, independent of the results.
right.
So because so the number of results possible in each of these matches is 8,
Mhm.
and only one out of these eight results is favorable to Balu, but
Right.
every other result means that Anita is going to win.
Yeah, correct. So, yeah, well said, Malavan. So, this was exactly Fermat's method also. So the way that Fermat reasoned was, he could see that if there are 3 more matches played, then the winner is going to be decided for sure. Of course, the winner could be decided earlier also. It's like Anita wins the next game, the tournament is over, she wins everything. But imagine that they are playing 3 more games, which is basically yeah, the number of points that is required to decide the winner. So now, if they are playing 3 matches, there are 8 possible results. So it could be that Anita wins all 3 of them. Of course, the tournament gets decided after the first game, but we will let the tournament run for 3 matches anyway. So now we will have 3 possibilities. It could be Anita wins all 3 games, or Balu wins 1 game, where AAB or ABA or BAA, or it could be that Balu wins 2 games, so BAB and BBA. And the other possibility is Balu winning all the games. So now there are totally 2 power 3 possibilities. Which is 8. And among all of them, Anita is going to win in 8 of these outcomes. So you have 8 of these possibilities, of which 7 of them are favoring Anita and only 1 is favoring Balu. Right. So now we assume all 8 because we are assuming all the games are independent of each other and both Anita and Balu have equal chance of winning the game. So now you are giving 1/8 probability for each of them. And if you are looking at the outcomes which favor Anita, if you just add all of them, so probability of Anita winning is 7/8, and probability of Balu winning is 1/8. So going by this logic, we should split the prize in the ratio 7:1, which is the probability of Anita winning and probability of Balu winning. So yeah, Ashwat, do you want to add something?
Sir, I had a slightly different way.
Okay, yeah, Ashwat, I'll come to you. Before that, I just want to ask others. So is everyone comfortable with this method of reasoning? Does anyone have a doubt? Okay, cool. So yeah, Ashwat, what do you want to say?
Sir, instead of listing out all 8, like we could just do it for Balu. So like even if Anita wins 1, then we know that Anita will win. So for Balu, that means that Balu needs to win all 3 for him to win. So so that means there's 1/8 probability for him. So Anita has 7/8 probability. Like 1
Okay,
times.
great. Yeah. So, Ashwat, your argument is basically we just need to calculate for Balu to win. And because that is easier to calculate, because Balu has only 1 path to win, he has to win all the 3 games. So, probability of that is 1/8. So, probability of Anita winning should be 1 minus Balu's probability, which is 10. So now, Fermat and Pascal are these 2 famous French mathematicians, and they were discussing this problem in like some 1600s, right? That is 400 years before now. And this was the method that Fermat came up with, where he's enumerating all the possibilities and he's able to calculate this. Now, Pascal, he calculated the probability in a different way. So I want to show you Pascal's method also. Yeah, this is going to be method 5, which is Pascal's method. So Pascal now imagined this probability as a kind of a tree. So what we mean by that is, right now the score line is 4-2, favoring Anita. And now if they are going to play a game, either Anita can win that. If that happens, the score line is 5-2 and Anita wins the tournament. Or the score line can be 4-3 if Balu wins, right? So now if we come to this branch, if it's 5-2, then it's kind of settled. Anita wins, right? But then suppose Balu won the next game and the scoreline is now 4-3. Now they play another match. Again, here Anita could win this match and the scoreline could end at 5-3. Or Balu could win that match and the scoreline will be 4-4. Again, here also, if this happens, that is after 4-3, if Anita wins, the scoreline is 5-3 again. But suppose it is 4-4, they have to play one more match, and Anita could win this match, and the tournament will end with the scoreline 5-4. Or Balu could win the match, and the tournament ends with the scoreline 4-5. So if this happens, Anita wins. If the other things happen, Balu is the winner, right? So now, can we just say that among these possibilities, there are 4 possibilities. Anita is winning 3 of them, Balu is winning 1 of them. So can we say that the probability of Anita winning is 3/4 and Balu winning 1/4? So can we basically say the probability of Anita winning is 3/4, Balu winning 1/4? Therefore, we should split it in the ratio 3:1, which is what we did earlier also in method 2. So how many of you do not agree with method or do not agree with the answer of 3/4 as the probability? Yeah, Malodin, you want to say something?
Sir, but they've played way more games than just 4 games. They've played 6 games. So if we include all of them, wait, I think there's an issue.
Yeah, right. So Shivansh, what is your argument?
So like at every point, there are 2 cases. So the probability of 4:3 being the score is half. So you have already half the thing there. So then
Right.
by time you reach the score line 4-5, it's already 1/8. So that's like 1/8 is 2/7/8 and not 3:1.
Correct. Yes. Vikrant, what did you want to say?
The same thing, sir.
Yeah, right. So here I am kind of assuming that all of these scenarios are equally likely. That is this 5/4, 5-3, and 5-2. But we have seen from yesterday's example with the dice problem, for example, that all of these outcomes are not equally likely. So now imagine this as a kind of a river flowing. So we are starting from 4-2, that is the score line. There is half probability of it taking this branch and going to 5-2, that is Anita winning the first game. So the probability of that happening is half, and probability of 4-3 happening is half again, right? So now this half of the river is flowing to 4-3, and that again splits further into 2 equal halves as 1/4 and 1/4. So the probability of Anita winning the tournament with the scoreline 5-3 is now 1/4. And again, in the next step, it still branches into 1/8 and 1/8. So now from this tree, you can see that probability of Anita winning is, it's basically all the streams that end with Anita winning the tournament, right? So here it could be 1/2 plus 1/4 plus 1/8, which is 7/8. And probability of Balu winning it is going to be, there's only one possible outcome, and that happens with probability 1/8. So like among of the big river that we start with, only the stream of 1 by 8 ends with the probability of Balu winning the tournament. So now here, basically the probability of Balu or Anita and Balu winning is basically 7:1. So this is the way that we should split the price. Note that Pascal's method and Fermat's method, they both give the same answer. The argument and the reasoning is kind of same, just that we represent in a different way, right? So this is how Fermat and Pascal resolved this problem 400 years ago. But now let me ask this question. Now let's assume that Anita and Balu are playing the tournament. And now let's try to generalize it for a general case R and N. So now imagine that to win, Anita needs R games and Balu needs S games. That is, Anita needs R points to win the tournament and Balu needs S points to win the tournament. Now, how should we split the price? So I will just give you 2 minutes to think about this in silence. After that, we will have a discussion and then of course I'll give the answer. So now the question is the same tournament rules, two equally skilled players. But now I'm not giving you the score line. I'm only telling you how many points they need to win. Anita needs R points to win. Balu needs S points to win. How should we split the price? So yeah, I'll just allow you to think for a couple of minutes and then we will discuss. Yeah, so if you would like to share your answer, just give a thumbs up. I'll call out to you and yeah, then you can unmute and share your answer. Yeah, Shivansh, I can see that you raised your hand, but I would like to hear from others also. So I'd like to give others a chance to speak. So yeah, Sanjeev, how would you approach the problem?
Sir, so I thought like first, let's say R is greater than S for now. So for every, so that means that the number of games A has to win is lesser than the number of games S has to win because the target is the same. So, sir, I haven't exactly completed, but I realized that for every one game A has to win, she gets an extra like half probability, then it halves that to 1/4, 1/8, and so on.
Okay. Okay.
That's all I've got.
Yeah. Okay, Madhusudanan, what is your answer?
Sir, adding on to Sanjeev's point, I can taking R is greater than S. R is greater than S. So that means, so the answer is that R will win is 1 by 2 to the power of 1 plus 1 by 2 to the power of 2 till 1 by 2 to the power of R. And the probability that B will win is 1 minus the whole this 1 minus the possibility that R will win.
Okay, fine. But now this argument needs to be symmetric with respect to R and S, right? So you are assuming R is greater than S and you are giving this. But then I should also be able to reason the other way and say that, so this is Anita's probability, this is Balu's probability. Balu's probability should be 1 by 2 power 1 plus 1 by 2 power 2 all the way till 1 by 2 power S. And Anita's should be 1 minus of this, right?
Yes, sir.
So, should these two things be equal? Will they be equal?
Not necessarily, sir.
Here comes the interesting part. In this example that we saw, I kind of gave you a convenient number so that yeah, I gave you a convenient number so that the probability of Balu winning just happened to be 1 by 2 power 3, or you are just able to take the sum of powers of 2. But then, if you are looking at a more general case, say Anita needs R points to win and Balu needs S points to win. Right. So first thing is the tournament is going to get decided in R plus 1 minus 1 games. Right. Because after these many games are played, either Balu will get S points or Anita will get R points. At least one of these two things will happen. So now imagine that they are playing 2 power R plus N minus 1 games. Right. Now, suppose if you are taking R to be some 5 and S to be 7, this is going to be 2 power R plus S is 12 minus 1, 11. So this is 2 power 11, which is actually something like
2048, sir.
Yeah. So now there are going to be these many possibilities. And yeah, this is not like easy to enumerate. Of course, you can do it with a computer or you can spend a lot of time and get the answer. But yeah, it's going to take forever, right? So now Pascal now came up with a method that is going to simplify this problem even in that case. So I'll speak. Yeah, right. So now what we want to find is among these. So now let's take a specific example. Say we are taking 5 and 7, right? So now what we are looking for is possibilities where A wins at least 5 games. So it could be that like Anita wins much more games, like Anita wins all the 11 games that they are playing. But we want the scenarios where Anita wins at least 5 games. This is going to be the probability of Anita winning. The number of possibilities by the total number of possibilities, which is 2 power n. And similarly, Balu winning at least 7 games. This will give the probability of Balu winning. Right. So now how do we calculate these numbers? So for this, you need to now consider all the different possibilities or all the different outcomes that can happen. So either if they play 11 games, Anita can win 11, Balu can win 0, or Anita can win 10 and Balu can win 1. So now you don't care which 10 games Anita wins. For example, Balu can win the first game or the second game or the fifth game or the last game. You don't care. You just get the number of wins. So you don't care about the order of the wins, but only the number of wins, right? So this is Anita, this is Balu, this is Anita, this is Balu. Goes on. It goes on till what? It goes on till the possibility where Anita just wins 1 game and Balu wins 10 games. And the possibility where Anita wins 0 games and Balu wins 11 games. Right. So now over here, if I were to write this sequence, so Balu wins 7, Anita wins 4, or Anita wins 5, and Balu wins 6. Right. So now, if any of these things happen, Anita wins the tournament. If any of these things happen, Balu wins the tournament. Right. But now, how do we calculate? That is, what is the number of possibilities for this happening? That is, Anita winning 9 games and Balu winning 2 games. So what is the number of possibilities of this happening? That we can actually calculate. There is a formula for that, but I want to show you another surprising thing, that this is nothing but the row of Pascal's triangle. So we can just get this, the numbers of all these cases, that is the number of ways in which Anita will win 9, Balu will win 2, or Anita will win 5, Balu. The Pascal's triangle, and this is nothing but the 12th row of Pascal triangle, right? So if you look at the Pascal triangle, just sum up all the possibilities for Anita winning, that is the sum from 11, 0, 10, 1 up till 5, 6. Those are all the possibilities of Anita winning, and the remaining things will be the possibilities of Balu winning. There is, of course, a formula for directly calculating this number, but this is how Pascal calculated from the Pascal's triangle. And this is the problem that actually led him to the Pascal's triangle. So the mathematical object for which he is now most famous for. You can see that this actually works in this example as well, right? So now over here, if you looked at the case where the score line was 4-2, so basically to win it was 1:3 for Balu and for Anita and Balu. So there, if you see, there is one way in which Anita will win all the 3 games. There are 3 ways in which Anita will win 2-1. 3 ways in which Anita will win 1-2, and 1 way in which Balu wins all 3 of them. So now, this would be the second row of Pascal triangle if you build the triangle. So 1, 2, 2, 1, 2, 1, 1, 1, 1, right. So this is nothing but the third row of Pascal triangle. All of these numbers and gave it to Anita, and added all of these numbers and gave it to Balu. Right. So now the answer or the method to calculate the probability actually is hidden in the Pascal triangle. So now the correct way of splitting the price for Anita and Balu is basically sum of let me just check once again. Right. So the way to calculate probability is nothing but the sum of the first S numbers for Anita. So here you are counting from 11,0 to 5,6. So basically 7 terms. And the remaining R terms or 5 terms, that would be the total which you give for Balu, right? So now you basically split the price in the ratio not R is to S or not R is to S or 2 power R to 2 power S, but basically sum of the S numbers of Pascal triangle, the row corresponding to R plus S minus 1. Basically here it's you add it and give it to Anita, and the remaining R numbers you add it and give it to Bal. So yeah, Madhavan, you have a question?
Sir, but can we also express this as some like n choose r?
Correct. Yes, it is. You can represent it in that way. Yeah, I will just share it on the slide. So yeah, there are just so many windows in Zoom. It's hard to keep track of it. Okay, so in a general case, when Anita needs R points to win and Balu needs S points to win, the way that you split the price is basically the first S terms of Pascal triangle and R terms of Pascal triangle. Now there's a formula to basically get this sum. Each term is actually nothing but R plus S minus 1 choose K, where that index K is running from 0 to S minus 1 or from S to R plus S minus 1 or like the end, right? So those who are familiar with this formula from combinatorics, yeah, you can just represent the summation in this form. R plus S minus 1 choose K, summation of the first S terms and summation of the last R terms. Those who are not familiar with this formula, it's okay. You can just think of it in terms of Pascal triangle. You will of course be learning this formula later in your school, I guess. But anyway, so this is the way to split the price. So now I want to go to another question. So now I want to show another game where it's a game of chance. So now imagine that we are playing a game, a TV show, right? So the game is this. There are two bins, X and Y, and there are 100 balls. 50 of them are white balls, 50 of them are black balls, right? And these 100 balls are distributed among the two bins. You don't have to distribute them equally. You can distribute them in any way. And a contestant chooses a ball at random from either bin. That is, first they choose a bin, and from that bin they choose a ball, right? If they pull out a white ball, they win the prize. Yeah, it could be a car or washing machine or a fridge or whatever. Anyway, they win the prize. If they don't pull out a white ball, if anything else happens, they don't win it. So now, suppose you are splitting the balls in this way. That is, bin X has 25 white and 25 black, and bin Y has 25 white and 25 black. Now, what is the probability that the contestant will win this game? So I'm just going to pause here for a couple of minutes. After 2 minutes, you can give your answer, right? So don't shout out the answer. Once you have the answer, just give a thumbs up. Yeah, Ashwin, do you have a question?
The answers.
Okay, fine. Answer means give me a thumbs up. Thumbs up means answer. Raise hand means I will assume that you have a good person. Yeah, so I can see that some of you have raised your hand or you are giving your answer, but I would like to give a chance to those who haven't spoken. So yeah, Malolan, Ashwat, Shivansh, I'll just like give a chance to others. So yeah, Ayushi Kumari, can you share your answer? What's your answer? Nandita, what's your answer?
I guess it would be 1/4.
Okay, what is your reason?
There's a 1/2 chance of winning in either of them, so it may become 1/4 because you don't know which one you choose.
Correct. But it could be that you go to bin X and you win with bin X, or you go to bin Y and you win from bin Y also, right? So, yeah, I can see that some of you already have the answer, but I will just hear from others also. So, uh, yeah, so Abhyuda, what do you think is the answer?
Sir, I think the answer is 1/4.
Okay, why do you say it's 1/4?
It's because since the contestant gets one chance to choose out of 4 bins, it would be 1/4.
But there are not 4 bins, there are only 2 bins.
Sir, I have a doubt.
Yeah, okay, go ahead.
So let's say he goes to bin X and he chooses a white ball. So does he have to choose from bin Y also? Or does the game
No, no,
end
no.
there?
The game ends. He just chooses one ball. Contestant chooses only one ball, and that's
Okay, sir.
it. So in this case, we can calculate the probability as basically either the contestant goes to bin X or bin Y. If he goes to bin X, he he has a half probability of getting the white. So yeah, maybe I'll go to Polypad and explain. Right. So for the first question, so either he can go to bin X or he can go to bin Y. Probability of him going to bin X is half. Probability of him going to bin Y is half. And within X, there is a 25/50 chance of him winning, of picking the white ball. And in Y also, if he chooses Y, there's an again 25/50 chance of getting the white ball. So basically, there is a 1/4 chance of him winning by choosing the white ball from bin X, or there is a 1/4 chance of him choosing from Y, and we add both of them together because either of them can happen. That means you add, and when you add, you get half, right? So the probability of him winning the game is basically half. So now let me go back to those slides. So now suppose bin X has 50 black balls and bin Y has 50 white balls. That is, you put all the black balls in bin X and all the white balls in bin Y. Now, what is the probability of the contestant winning the game? Yeah, if you have an answer, just raise your hand.
Sir, I have a doubt. Does the contestant know which bin has which color?
No. The contestant does not know. Yeah, Vikrant, what do you think is the answer?
Then I think it's probability is 1/2 because if we goes to bin X has a 50% chance of going to bin X, and in that since there are no since there are no white balls, there's 0% chance of picking a white ball in a 50% chance, so 0% in overall X. But in bin Y, there's another 50% chance of going to bin Y. But in that, it has all 50 white balls, so 100% chance of picking a white ball. So so that's a 50% chance in
Correct.
total.
Yeah, correct. Yeah, you've also given the proper reason. So now imagine that you spread the balls like this. That is, bin X has 10 white and 40 black. Bin Y has 40 white and 10 black. Now, what is the probability of the contestant winning? Yeah, so initially the contestant does not know what X has, what Y has. That is something that only you as the game show host knows. So Madhusudanan, what do you think is the answer?
Sir, the answer is still 50%, and I have come to a conclusion that in any order the black and white balls may be placed, the answer will always be 50% as a constant.
Okay, right. Yeah, Ashwat, what do you want to say?
Same thing, sir. It's 50%, and like Madhusudan said, I think I have a proof.
So, okay, Ashwat and Madhusudan, you are both saying that it is 50% in the third case also. But Ashwat, do you also agree with Madhusudan's statement that it will always be 50? That is, no matter how you split the balls, the contestant has a 50% chance of winning the game. Do you also agree with that?
Yes, sir. Yeah, I have a proof also.
Oh, right. So, Ashwat, what is your proof?
So like actually, there are like two ways you could think about it. So choosing white is the same as like choosing black, since it's like symmetric. So wherever you have white, you can just swap it with black, and you could get the same statement again. So it would technically be half. Another way you could do it is, if the number of white balls in the first bin is W, and the number of black balls is B, then in the second bin it would be 50 minus W and 50 minus B, like for each one. So then it would be the probability of picking it out of the first bin, picking a white marble out of the first bin, would be half times W by W plus B. Picking it out of the second bin would be half times 50 minus W divided by 100 minus W minus B. And then, so adding that together, you get half times like half plus, half times W by W plus B plus 50 minus W by 100 minus W minus B. Then it'll just be the summation of that for all W and B. And but then in that bracket itself, like W by W plus B plus 50 minus W by 100.
Okay, so Ashwat, I think I'll stop you there because yeah, you got the correct idea, you got the answer also, but yeah, I think it's becoming a little difficult to follow. Yeah, Shivansh, do you have something to say?
No, sir, it was the same as Ashwin.
Okay, right. So now my next question is actually this. Imagine now you are having the same game show, same rules, but now how can you rig the contest in favor of the contestant and how can you rig it against the contestant? Is it possible at all? Because Ashwat has just proved that the probability of contestant winning is always half or 50%, right? Is it possible to rig the contest in favor of the contestant? I'll just give you 2 minutes to think about it. Then we.
The doubt, sir.
Okay, what's your doubt?
So does it mean like they tell the contestant where the ball is?
No, you don't. You don't tell the distribution. You don't give any information to the contestant. Contestant still does the same thing. Chooses one bin at random and chooses one ball from that bin. Then how can you rig in favor or against the contestant? You can't give any extra information to the contestant, but you can decide on the way you distribute the balls.
Oh, that's what they mean by rig, sir.
Yes.
Oh, okay, sir.
So it's not 50 white and 50 black.
No, number of balls is also fixed. 50 white and 50 black only.
Okay, sir.
Hello, Ashwin sir, a gentle reminder. We are only left with the 10 minutes.
Sir, I think you're on mute. We're not able to hear.
Yeah, sorry. Yeah, I was asking Nivedita. Nivedita, can you tell whether it is possible to rig the contest? Farhan, what do you think?
Sir, I think that there is no possible chance that even we can rig rig the rig this to the favor of the contestant or go against and rig it to the content to the contestant.
Right. So Farhan, you think no matter how we put the balls, contestant has a 50% chance of winning, right?
But sir, if we tell them that one of these, if we tell that in in the bin X it is white,
No,
they can.
we are not going to tell them that. We are not telling them that. So yeah, Manolan, what do you want to say?
No sir, it is not possible.
So same thing.
Okay, right. Now, what if I told you it is possible to rig the contest and it is possible to rig in favor or against the contestant? That is, if I like the contestant, I can increase the probability of winning. And if I don't like it, I can actually decrease the probability of winning. So now I'll show you how. So now let me go to
Sir,
qualified.
So I have a question.
Yeah, Sanjeev.
As a host, I allowed to say an extra statement which can rig.
No,
Like
no,
not
no.
an obvious one like a stick or switch
No,
situation.
no, no. No, so you are not going to give any clue to the contestant. Yeah, you're not cheating in that way.
Should the balls be equally distributed?
No, that is the point. So now, let's just look at this scenario.
Sir, I have a doubt, sir.
Yeah, what's your doubt?
So there is a necessity that 50 balls should be in bin X and 50 balls should be in bin Y.
No, there is no necessity. In fact,
Sir,
that's
I
what
was,
I'm going to use here.
so I was thinking about that only, sir.
Sir,
So what I will do is, I will put one white ball in bin X and I will put 49 white balls and 50 black balls in bin Y. So now if I do it like this, what is the probability of win or what is the probability of the contestant winning? So now probability of win is the contestant can choose bin X or bin Y with equal probability, half half. But if they choose bin X, and if they draw a ball, that is going to be white for sure. So here they are sure to pick out a white. But with bin Y also, there is like a 49 out of 99 probability of them picking out a white ball. So which is like almost half. So here, this is like a half plus half into 49 by 99. Here I'll just kind of round it off so that it's giving like a nice number. Plus almost half. So here they have an almost 75% chance of winning if I keep the balls like this. Now suppose if I keep it like this, that is in win one black ball, and then win Y, I keep 49 black balls and 50 white balls. So now what is the probability of winning? Here, it's like if the contestant chooses bin X, which will happen with half probability, they are sure to lose. So it's half into 0. But if they choose bin Y with other half probability, it's again still half only. That is, it's like 49 by 99, right? So here they will have an approximately 25% chance of winning. Compared to our earlier case where we kept 50 balls in X and 50 balls in Y, so the contestant had a 50% chance of winning, right? So now here I'm not cheating, I'm not giving any information to the contestant, but still, just by the way I rearrange the balls, the contestant has a better chance or a worse chance of winning at the game. In fact, like technically I can even do this. That is, I can even claim that I will put 0 in bin X.
Hello, sir. Just a gentle reminder. We are left with the 2 minutes only. But if you wanted to take some doubt or the topic is remain, we can stretch up to 5 minutes.
No. We are going to finish in 2 minutes.
Okay, sir.
So yeah. So if I put nothing in bin X and if I put everything in bin Y, so here it means if the contestant chooses bin X, they will not draw anything. So technically they are not drawing a white ball. So here you can say that, yeah, they have a 1/4 chance of winning. But then the interesting thing is, sorry, yeah, correct. So now here, the interesting thing is, if I have the distribution of one white ball and everything else in bin Y, the contestant has a 75% chance of winning that game. But if I just make one change from here, that is, I pick the white ball and I put that also in bin Y so that bin Y has everything, the probability of them drawing the white ball reduces now to 1/4. So just affecting that one ball changes the probability from 75% and brings it to 25%, right? So this is an example where you have a game that looks like a fair game initially. And of course, I purposefully gave you numbers so that it feels like you can't rig the contest, that the contestant always has a 50% chance. But actually, if you bend this other assumption slightly, that you need to keep 50 here and 50 there, you can see that you can favor the contestant or make it go against the contestant. So now I'm going to stop here for today, but I just want to leave you with these two problems. So the first problem is, suppose Anita and Balu roll, both of them roll a pair of dice. What is the probability that Anita's total is bigger than Balu's total? Yeah, so here we will not have time to discuss these problems, but this is just for you to think about and for you to work on. I will be sharing the slides and of course the polypad with you. So you can of course think about it later offline as well. So first question is, if both Anita and Balu roll a pair of dice, what is the probability that Anita's total will be bigger than Balu's total? And how will you calculate? So this is one question. Another question, which I kind of skipped earlier, was this. That is, yeah. Yeah, so I didn't get to answer the question, a homework question from yesterday, but so for 3 dice the total being 14. The homework question for you was to get it for 12, but yeah, that I will not discuss over here. So yeah, I am going to stop here for now because it's 6 o'clock. So yeah, two of you are raising your hand. So we'll just finish this discussion quickly. Vikrant, do you want to say something?
Sir, I have a doubt, sir.
Yeah.
The doubt is that why is the probability of white winning lesser if 50 white balls and 50 black balls are placed in the one container and 0 balls in the other container? Or is the probability greater for white to win when one black ball is kept in one bin and 49 blacks and 50 whites in another bin?
Okay, so when you place everything in one bin, when you place everything in bin Y, the probability of winning is 1 by 4. When you place one black ball in bin X and everything else in bin Y, it is slightly less than 1 by 4. Or no, it's slightly greater than 1 by 4. So worst case is when you put everything in one bin, because if they pick the empty bin, basically they can't draw a white ball. So yeah, then you are saying that is not allowed. So basically they don't win. But if you put that one black ball, it's still like very close to 1 by 4 only, but it is like a tiny bit more. It's basically like the difference between 50 by 100 and 49 by 99. So yeah, it's almost close to the same number only, 1 by 4. Yeah.
So if you want to make them lose, the best way is to put all the balls in a bin.
Correct. Yes.
And the best way is the one white ball thing.
Correct. Yes.
Oh, okay.
So yeah, I'll hand it over to Prathamesh. Yeah, Prathamesh, you can wind up the session.
Hello? Okay, sure, sir. Does anybody have any doubt? Or we're ready to wind up? Okay. Thank you, sir. We have a flawless lecture today.
Yes.
Uh,
Thank you so much, sir, for
Swasti, I think we can end the meeting.
Yeah, before we end, I'd just like to thank sir once. These sessions were really amazing. We learned a lot about probability, sir, especially about the basics and the intuition behind the game. I think we all had a lot to take away from that. So thank you so much, sir, for taking the time to take these sessions.
Yeah, yeah. Thank you guys for being part of this session. Yeah, and thanks to the organizers as well and the RAM team. So if you want to discuss something, you can stay back. Otherwise, I think you can leave. So yeah, if you have something to discuss, yeah, maybe I'll just hang out for like 2-3 more minutes.
Thank you. Thank you, sir.
Thank you, sir.
Thank you,
sir.
Thank you.
Thank you,
Thank you, sir.
Thank you, sir.
Thank you, sir.